Uh, Shirin, you can start.
Bismillahirrahmanirrahim. Assalamualaikum and hello everyone. Welcome to today's second sections on structural equation modeling using Smart PLS. Thank you to all participants for joining this amazing webinar that we have organized. This session has been organized by Faculty of Applied and Human Sciences UNIMAP together with Platform for Research and Development. To the new participants, welcome and don't forget to subscribe our channel. Before I move ahead, I would like to introduce our guest speaker for today, Dr. Parukuma, to the new participants. Dr. Parukuma is a researcher with 10 years of experience and owns PhD in commerce. Dr. has been awarded the Best Business Academy of the Year award by Indian Commerce Association for the Best Technical Research Paper. Dr. Paru is a very professional and knowledgeable person in conducting corporate training sessions on Smart PLS, Mendeley, Advanced Excel, and SPSS. Dr. able to deliver the knowledge in an easy and understandable manner, so I hope participants will stay focused until the webinar ends. If you have any questions, please drop at the chat box and Dr. will answer during the Q&A session. Without further delay, I would like to hand over this session to Dr. and request her to start this session. Okay, you may go, Dr.
Thank you so much, Shirin. It's a pleasure to be back again on this platform. Thank you for the warm welcome. Thank you, Professor Ramanul, for again, giving me a platform to share my little bit of knowledge with the budding researchers. So great. Good evening, everyone. So in the earlier sessions, we actually talked about what is SIM, what is Smart PLS. We actually worked upon how to make a diagram in the Smart PLS, how to work with respect to the reflective constructs, the formative constructs, how to do the measurement model analysis. That was the first thing which we did when we started with our first session. Now in today's session, first I'll walk you through the analysis of the structural models. Now my measurement model is already complete. It's in the video one. Now in this one, we'll start with assessing how good the structural model is. And then finally, we'll keep on adding some of the other things in the model, that how to make that model, more interpretable, how to add implications to your paper with respect to the analysis, with respect to the results which you obtain. So we'll do it with respect to that. So just let me first quickly go through the quick structural perspective. What are the things you should remember when you are working on the structural models, and then we'll go towards the software. So let me just share the screen with all of you. So just 1 minute. So when we start with the structural model, so there are a few things which you have to understand. And as I told you in the first video, that in the Smart PLS, the full model is drawn at the first go. So we actually start with the structural model, but we assess the measurement model and then we assess the structural model. But Smart PLS only works on when it is a full structural model. So what are the things we should look for in the structural model is, the most important one, we always check the significance. That what is the significance of the various, constructs. That is really important. The constructs, how your constructs are working on, how your constructs are behaving, which one is significant, which one is not significant. That is our main point of concern. So you should always remember that your constructs should behave, as per, when we are talking about that they should, just 1 minute, that, when we are talking about the constructs, so then my independent variables, my dependent variables, does it having a negative relationship, does it having a positive relationship, does that relationship is significant, how come we say it is significant? So then it comes to the level of significance, 5% level of significance, 1% level of significance, depending upon the studies on which you are working on. Then along with the t-test and the p-value, you should always check for the bias corrected confidence interval. This is also really important, and I'll show you that how it is calculated, how it is there, in which perspective it is shown. So it actually is a better parameter as compared to the p-value. So as per the literature, it is being said that you report the p-value, but also it is really important and mandatory to remove the bias corrected confidence interval. Then the next thing we should check is the explanatory part of the model, which is determined by the R square, which is actually how much percentage is explained by the independent variable, by the dependent variable for the independent variable. So that is always, remember, it is in sample. So why we are saying that this is in sample? Because this actually is with respect to your sample only. The sample, the data which you punched in the model, so that is why this is in sample. As per the literature, as per here et al., so they have given these threshold values. So these threshold values say that if your explanatory power is less than 0.25, then it means it is not a relevant model. You must have left, to ask something from the respondent. It is not a complete model. If it is between 0.25 to 0.5, then we say it is a weak explanatory power. 0.5 to 0.75, so it is a moderate one, and greater than 0.75, so it is a substantial or a strong explanation power. We'll talk about it. But just reporting the R square doesn't help you. Why? Because R square is a kind of matrix which actually increases with the number of variables. So if you keep on adding the variables, no matter whether they are significant or not, the R square will increase. The R square will increase. So it will not give you the better perspective, it will not give you the good results, it will not give you a better picture, a wholesome picture about your model. That is why, the researchers recommend that we should also represent the adjusted R square. It is also suggested that go for representing the adjusted R square, because it actually tells you that if a variable is in the model or it is deleted in the model, deleted from the model, then whether the explanation power of the model increases or decreases. So if you are adding a variable in the model and your adjusted R square increases, that means that variable is actually contributing to your model. Fine? So I'm repeating again. R square will increase as the number of variables or the constructs increase in the model. Adjusted R square tells you that by adding some of the variables, whether you are able to improve the explanation, whether that variable is actually helping your model explain more about the dependent variable, that is explained by your R square. Then comes another part. So this is about the explanatory. Now the people say that why we should also check the predictive power of the model. So for assessing the predictive power of the model, so we have to give the value of the Q square. It is known as the predictive relevance. It is known as the predictive relevance. And also we say that it is out of the sample predictive power as well. But this predictive relevance is really important. Now what it is telling you? It is telling you that how good your model is able to predict. How good your model is able to predict. So PLS helps you in calculating this value. Again, the threshold prescribed by the here install, that if it is less than 0, that means no predictive power of your model. So whatever you are doing, it is only suitable when your same data is applied to this model. So what is the use when I am not able to apply to some other data, some other model? Nobody will be able to replicate my study. So that means there is no usability of my research. So they say that at least your model should have a medium predictive power. Medium means the value of the Q square should be between 0.25 to 0.5 or 25% to 50%. Then we say that this model has medium predictive power. And if it is greater than 50%, oh great, your model has too much predictive power. So your model is able to predict the dependent variable, because ultimately my core answer, my core thing is all about the dependent variable. So my model is able to predict the dependent variable. So these are some of the starting things which you will see. In terms of predictive power, we have the two ways to do it. So we'll talk about that. Now let's just move to the software and see how the things work in that. So this is a clean canvas we have, right? So let's start doing some drawing on this canvas. So I have some of the data with me. Fine, so it has attributes, it has switching cost, it has performance, it has likability. So let me add some of the constructs here, drag them on the canvas and see how we are able to work with the model. So I'm just dragging some of the constructs and then we'll start. So just a simple model I'm putting up here. So let's quickly name them. We name them using F2 if you remember, or right click. So we say it is customer loyalty. Here we are saying it is likability. Then we have the attribute. And here we are talking about the performance. Fine. So let's quickly shift them. Let's connect this simple model. So I'm saying customer loyalty, likability, and the attribute impact the performance of a product. Fine, or the performance of someone we are talking about here, so it impacts the performance. So this is a simple model I'm talking about here. So I have 3 independent variables and 1 dependent variable. We already checked the measurement model of this because this is the whole model we make. So first we check the measurement model, so we already checked it. Now we are good to go with the head to the structural model analysis. In the structural model analysis, what you have to do is click on the calculate. In the calculate, we will now go for the bootstrapping. We will now go for the bootstrapping. So we'll click on the bootstrapping. A new window pops up. Here, as per the latest recommendation, you should do the bootstrapping of 10,000 samples. You should do the bootstrapping of 10,000 samples. See, again, I am re-emphasizing here, Smart PLS is a beautiful tool, and the best part is that they have mentioned each and everything with respect to the requirements, with respect to their meaning. It is very clearly mentioned here. See, subsamples are created with the observations randomly drawn. So randomly drawn from your own sample with replacement. So it is done 10,000 times actually. Fine. So to ensure the stability, the number of subsamples should be large. For final results, large subsamples, example 5,000. So earlier the had 1,000 subsamples. Now, as per the latest 2021 paper, so research they recommended that one should go for 10,000 subsamples. Now, as of now running, I would go for 500. We go for complete bootstrapping, and here we will select the bias corrected accelerated bootstrap. Here you will select bias corrected accelerated bootstrap. 2-tail level of significance, 5% level of significance. We are keeping it here. And now simply we will start the calculations. We will go ahead with calculating. So it will do the calculations. So it will run. Can you see running 5,000 samples? It is written here. Bootstrapping running this for samples. Now it will run and it will give us our results. So bootstrapping is used for your hypothesis testing. So your hypothesis testing results come when you do the bootstrapping. Always remember this thing. So let's start reading these results. How to read them now? That's the thing. So again, this is a table. You can simply copy this Excel format. If you click on the Excel format, let me show you. So I click on the Excel format. Now I open an Excel file. Now once I open an Excel file, I can simply paste this table as it is onto the Excel. So just have a look here. So I'll simply pressing the Control V, or we say the tape, simply, and see the table which is calculated by the Smart PLS. It is directly copied. Either you want to copy it into your Word file or the Excel, your wish. Now, what are these? These are your paths. These paths are here. See? Loyalty to performance, likability to performance, attribute to performance. Now on the diagram, what is being shown? So on the inner model, inner arrows, we say it is the p-values. It is the p-values. Again, on the outer model with respect to the items, all the p-values are mentioned here. Within the circle, it is the R square. Within the circle, it is the R square. Now let's try to read this. So this is the result. You have to read the first original sample. This is actually your beta value. Beta coefficient. So what it is telling you, that attribute to performance is significant in impacting the performance. So if attribute changes by 1, so performance will increase by 0.597. So if the attribute increases by 1, the performance increases by 0.57. So there is direct significant relationship or positive significant relationship. See, another beauty of the Smart PLS, the values which are by default less than 0.05 are highlighted in green. So green says it is significant, red insignificant. Both the p-values are greater than 0.05 are level of significance. So customer loyalty and likability both are insignificant in impacting the performance. Only the attribute is significant in impacting the performance. Now, see the third tab, confidence interval bias corrected. In the confidence interval bias corrected, these are the last two columns which you have to represent the bias corrected results, the lower and the upper bound. So the lower and the upper bound, when you say that there is a definite zero in between the class intervals. Why definite zero? Because it is minus and it is plus. So definitely there is a zero in between them. Again here there is a zero in between them. So when there is a zero, then it means it is insignificant. When there is no zero, see positive positive or negative negative, that means there is no zero, so it means it is significant. So just do not rely on the p-value. Cross verify with respect to the confidence interval as well. So let me show you how to write it into your papers, how you should present it into your papers. So I'm just copying both the models and pasting it here, removing the values which I don't require. So I don't require this. I want to show the statistics. That's up to you. You want to show p-values, you can show the p-values, or sometimes what we do is we write, we use a star mark. We use a star mark for which, p-value is significant, which path is significant. So here, bias corrected confidence interval lower, bias corrected confidence interval upper. Here you can say it is a beta, you can simply write T statistics, and here it is. Your model is ready, your structural results are ready to be presented. If you want to add one more column to it, so you can add the results, or you can write the hypothesis. I can write it here in the beginning. Hypothesis. I may say this is my H1, H2, H3, and here in the result I can write that fail to reject, and here as per my hypothesis I am saying that reject the hypothesis. So this makes your structural model results complete when it is just a simple basic model, just a simple basic normal model. So this is your structural model. Oh, we should write also one more thing here. The value of the R square. So what was the value of the R square? See in the quality criteria. R square 0.548. 0.548. So 54.8% of the variations in the performance is explained by attribute, loyalty, and the likability together. Together. Not single, together. We should also mention the adjusted R square. So let's see that as well. So R square adjusted is 0.534, and let me show you the change in the adjusted R square as well. So let's say this is a model. Excuse me. So let me add one more construct in this model. So let's say I'm adding the quality. I'm adding the quality here. I am aligning it to the bottom, connecting it to the performance. So if I want to actually see that the quality is actually adding something to my model, I would be checking the adjusted R square, not the R square. The R square will increase because you are adding a variable to your model. So let's do the bootstrapping again. Same thing, doing no change, and just the calculations. So just let's see, whether our adjusted R square improves, whether the quality is adding any good to my model or not. So let's see. So let's first always by default comes the significant or non-significant results. So here it is. The quality is significant. See, the quality is significant. So that's great. Let's see the adjusted R square. So let me go to the adjusted R square, and can you see? Now it is 0.610. So now this has increased to 0.610. That means this variable is actually adding some value to my model. See, the R square will by default increase. Whether you add an insignificant variable, whether you add a significant variable, R square will always increase. The main thing which you should check is adjusted R square. So adjusted R square has increased. That means by adding the quality in the model, my explanation power of the model actually increased. I hope this point everyone got it. So I can pause for 2 minutes here, and we can have a quick question if we have some questions till now. Right now we are not talking about the moderator, we are just talking about a simple model. So this question will not be appropriate. So the applicability of the Smart PLS and the Mac you have to check, but I think it is available with respect to the Mac version as well. So check it on their website. I think it is available. Next question. Any other question we have? No questions. So I'm assuming that you understood the overall working of the structural model, how to report your results, how to tell them that which hypothesis you are failing to reject, which you are actually rejecting, and then also the most important part is that which variable is significant, which is not significant, reporting the R-square, adjusted R-square. Second order, right now we are not doing the second order in this video. So sorry about that. See, again, the assumption part we have discussed in the first video, not here. So here the assumptions will not be checked. The assumptions are with respect to the starting one. The regression, the major issue is with respect to the multicollinearity only. And here we check the multicollinearity when we are assessing with respect to the measurement model with the help of BIF. So again, we will not talk about the things here. Multicollinearity, yes, we check it here as well. Any other questions? No. Okay. So let's get back. Just give me 1 minute. Let me share the screen again. Okay, that's a good question. That is, let's suppose the p-value is significant, but the bias corrected confidence interval is not significant. Then, as per the literature of the here installed, they say that you should focus on the bias corrected interval. You should run this model again. Try to run more iterations. Run this model again. Fine. Run the bootstrappings again, and then you will be able to have a better result. And obviously, focus and present your results on the basis of the bias corrected interval, not just on the p-value. It is recommended that not just on the p-value you should represent. It should be on the basis of the bias corrected, but again, you should run the bootstrapping again. Okay, so let's just quickly come back to the Smart PLS. Shakib, I just answered this question only. That please, when you give the results, so please focus on with respect to the bias corrected confidence interval. Do not merely focus your results, do not merely present your results on the basis of p-values. Rerun the bootstrapping with maybe more higher subsamples to be 100% sure that whatever you are reporting is actually correct with respect to the perspective. Now this is a simple model we just talked about. Now let's see how good is the predictive power of this model, how good is the Q-square value of this model. So to do that, okay, so let me do one more thing. The likability and the loyalty were not coming significant. So I'm removing these two from the model as of now, so that I can have a better view of the thing. So now, to calculate the predictive power of the model, there are two techniques. One is blindfolding and the other is PLS Predict. Blindfolding, both of them are outsampled, but in the blindfolding actually, some part of the sample is taken out, not all part actually. Let me show you how. So let's suppose, so this is my respondent. This column represents my respondent 1, 2, fine. So these are my respondents, respondent number 1, respondent number 2. Here are your variables or the questions that you asked, so x1, x2. So these are these set of questions, the statements that you have asked from the respondents. And then, they have given you the values, they have given you the ratings. So these are kind of, the answers they have given you. And likewise, let me just populate some of the values here. So let me just populate. Now, first technique which I'm talking about is blindfolding. Now, what exactly does blindfolding mean? It is very important for you to understand because two techniques we are going to talk about today. So the blindfolding technique says that I would not remove whole respondent data. Respondent will remain here. Respondent will not go anywhere. It will remain in my model. But I will do what? I will remove some of the in-between responses. So for example, I remove, let's say, let me just, so let's say I remove this. I decide there is a one thing which we have to decide when we are talking about the blindfolding technique. So in the blindfolding technique, you have to decide on the distance. That after how many data points, some of the points should be removed from my model. How many data points? So remember, which we are talking about is here is how many data points my values should be removed. So let's suppose I take 3. So now what I mean by 3, every third value will be removed, and it goes like this. It will start like this, then it will move to here, and then it will move down till here. So it will go like this. So these values are removed, then this will be removed, 1, 2, 3, this will be removed, 1, 2, 3, this will be removed. Likewise, some of the data points are removed from your whole data. So respondent 1 is existing, but some of its data points are gone, right? And this will be done multiple times. So on those missing values, now these values are removed. These do not exist anymore. So these are blank values now in your respondent's data. So these are like missing data. Now what the software does is that software in the backend replace these values with the average of these, with the average values. So in the backend, all these missing figures are changed to the average value, and then the process and the calculation happens, the iteration happens. These iterations which actually trying to predict, they actually try to now predict these values and compare them with the original values. And find out their difference, or what we say is the errors. So in simple words, what we are saying that the data omission model, this is a data omission model. So here the omitted values are predicted. So the difference between the actual values and the predicted data points is actually nothing but it becomes the input for the Q square. It becomes the input for the Q square. Now, how to decide which value to take for the distance? It is recommended that this value should be between 5 to 7. Again, depending upon you, but it is always recommended that when you think of dividing it, so focus on that number of observations. So focus on your number of observations and see which is the best way to divide it. So it is no hard and fast rule. Again, it is your wish. Rule says go for 5 to 7 as well. Even some cases you will find that d equals to 10 is also used. So 10 is also recommended, no problem. By default, you will find always in this software that the d is equal to the 7. Now, once these errors are calculated, so for calculating the value of the Q square, so we use 1 minus sum of the square errors upon sum of the squares of the total one. So this is actually your naive benchmark. This is actually your naive benchmark, and this is the difference of the errors. And always remember, predictive power will be for the dependent variable, because ultimate goal is to predict the dependent variable, not the independent variable. Independent variable are used for predicting it. Independent variable are used for predicting it. Another thing, blindfolding technique is for the reflective construct. It is for the reflective constructs. It is not for the formative constructs. Fine. So again, I am repeating, it is the iterative procedure in which the different parts of the data are omitted. These omitted data points are actually replaced by the mean value. The difference between the actual omitted and the calculated or the predicted point becomes the input for the Q square. Fine. So this is one methodology. This is one methodology. Now, how this methodology differs? How this methodology differs with respect to when we are talking about, let me clear all this. So how this methodology differs with respect to when we are talking about the blindfolding with respect to Pls Predict. So let me just clear all this. And now let me show you the comparison with respect to the Pls Predict and the blindfolding. So in the blindfolding, we understood we are masking. So let's suppose if I take D as 5. So like the software can start from any of the numbers. So let's suppose this time it starts from this number. So it starts by omitting this number. So first it omits, let's say 3, then after 5, 1, 2, 3, 4, 5. So D 5. So every fifth observation will be omitted. Every fifth observation will be omitted. So it is omitting fifth observation. Now let's say. Now see if you have, if I take 5, so almost the same respondent will be removed from my data because I have an even number of observations. So when you have even number, take the odd number as your D. When you have the odd, take even number as your D. So that the whole responses, that the whole respondent doesn't go, actually some of its responses go. Now when we are talking about the Pls Predict, so what is the difference? Again, let's put this whole data here again. So this is your data now. Now what the Pls Predict is doing? Pls Predict is actually removing some of your data. Means it is actually removing your respondents. So whole of your respondent data goes out. So all these in the red goes out. Fine, they do not represent the data. So now your data is just of 6 respondents. If I'm talking about this 10, so it is just of 6 respondents. How this is dividing this? So here, like in the blindfolding, we calculate the distance, or we say it as D. So here we have to calculate K. Why? Because Pls Predict works on K-fold cross validation process. It works on K-cross validation process in which your sample is divided in the training data and the testing data. Training data and the testing data. And it is done on the basis of the K. It is done on the basis of the K. Now, how to select the K? Again, there is a caution which you have to maintain while selecting a K, that the training sample should meet the minimum sample size criteria. So it should meet the minimum sample size criteria. So if for running the model in the Smart PLS with respect to your variables, it is suggested that you should have at least 100 observations, minimum 100 observations. Then your training data should have at least 100 observations. Again, I am explaining. So let's suppose if K is equal to 10. If K is equal to 10, then what is training and what is testing? So here it is. Let me put it in different ways. Training and testing. So the training will be K minus 1 and the testing will be that 1. So training will be 9 and testing will be 1. Testing is also known as hold out sample, and that is this sample on which the prediction will take place. So you have a total sample of, let's say, 200 observations or 200 respondents I'm talking about here, right? So let's suppose you have 200 observations. Now for the training, your data will be divided into K minus 1. So if K is 10, so the training data would have, how will we be dividing it? Can anybody put it on the chart so that we can have equal? It is 10 parts. It is 10 parts. So your whole sample is divided into 9 parts and 1 part. Fine. So 9 part goes into 1 and 1 part goes to the testing. 1 part goes to the testing. So again, sample of 20 observations, sample of 200 observations. So in short, what I will say 20 observations in each sample. 20 observations in each sample. How did I arrive at this? Very simple, 200 divided by 10. It is 10 parts. So dividing my 200 observations into 10 parts. So each part will have 20 observations. Now 9 parts will be kept for the training. So 9 means 9 multiplied by your 20 and 1 part will be kept for testing. So finally, the training will be done on 180 samples, 180 observations, and 20 observations would be used for predicting. Fine. So what I am doing is, I am running my whole model on 180 observations. Earlier, I ran my model on 200 observations. If you remember, in the blindfolding also, we ran the model on 200 observations only. We run the model on the whole data. Just some of them are replaced. But here in the Pls Predict, we are not running on the whole model. We are on 180 observations and we are actually keeping 20 observations aside. So that is why we say Pls Predict is more of an out of sample, because these 20 observations are not at all included in your model analysis. So you are building your model. So we are building our model on 180 respondents, right? And once this model is made, we will check the predictive part by predicting the holdout 20 respondents. So how good we are in predicting. Then it tells you about the predictive power, the out of sample predictive power of the model. Let me take another example. So let's say you have the sample of 200 observations. Now in this case, you are saying that k is equal to 5. Then each fold will have how many observations, how many respondents? It will be very simple. 200 divided by 5. So it is 40. Each fold will have 40 observations. So what is my training sample now? So my training sample will be 4 into 40, 160 observations, and my testing model will be 1 multiplied by 40 or 40 observations. So I am running my model on 160 observations, 160 samples, and testing the results on the 40 to understand the predictive power. So let's just pause here to have your questions with respect to the quick understanding of blindfolding as well as your Pls Predict. Any specific questions? See, I don't know about ArcGIS. I don't have any information, Emma, which kind of a software you are talking about. You have to run the Smart PLS and save. Any other question with respect to the understandability of the Pls Predict or the blindfolding? If not, then we'll start with the demo of these two. So no questions? Okay. So let's go to the software there. Go to the calculate. In the calculate, here just below the bootstrapping, it is blindfolding. So let's click on blindfolding. Now here, if you see omission distance, by default I told you it will be 7. So it is a systematic pattern of data point elimination. Prediction in the blindfolding procedure depends upon the omission distance. Fine. Suggested values used around 5 to 12. Now, for example, if you choose D is equal to 7, then every 7th data point of the target construct indicators are eliminated in a single round. Fine. Since again is an iterative process, so many rounds will take place. Fine. So the 7 we have kept, so 7 rounds will take place. The number of blindfolding round always equal to the omission distance. So 7 rounds of this omission will take place. 7 times, some of the other values are eliminated, and then it will run again and again to find out the Q square. Now let's calculate. I'm going for the 7, or let me go for 6. No. Let me go for 6. Let's suppose I go for 5. Let me go for 5. I have only 99 observations here. So let me go for 5. So here the results are, see, if you see here, SSO, SSE, same, sum of the square errors, sum of the square root observations, and here is the value of Q square. Can you see only the value of Q square comes for the dependent variable, not for the independent variable. Fine. So always remember, prediction is for the dependent. So it is 0.298 or 29.8%. And if you remember the threshold, here is the threshold.
So, Dr. Parul, yes? You have to share your screen. The screen is not shared.
screen is not shared. Oh, I'm so sorry. I'm so sorry. So let me do it again. So this is my model. Now in the calculate, we go for blindfolding. In the blindfolding, if you see here, the omission distance details are very clearly mentioned. Fine, and it will be done number of times. Now, how many number of times? The number of times here, the distance which you mentioned, the number of blindfolding rounds will always be equal to the omission distance. So we have mentioned 5 here. I have 100 data set only on which I am working right now. So I've used this lower one. So it will be run 5 times. Fine. So one time some set of observations are removed. In the second iteration, other set of observations are removed. Third iteration, another set of observations are removed. Then goes for 5 such rounds. So if you see 1, 2, 3, 4, 5. After 5 rounds, it shows you the result. So here it is Q square in the last column, 0.298. And if you remember the threshold, so the threshold was that the value of the Q square, if lies between 0.25 to 0.50, then we say it is medium predictive power. So this model has medium predictive power. Now how do you present this result? Now no need to represent the full table. Just below this, you can, below your structural table only, or within the text, you can simply write the value of Q square. Nothing else. You can either write it here or you can present it in your text when you are writing down. I will show you also that how we should write. So in that you should represent like this. So this is the simple blindfolding technique. First technique. Second technique now. We go to calculate again, and now we are checking Pls Predict. Now we are checking Pls Predict. So let's click on Pls Predict, and now see here. Number of folds 10, number of repetitions 10. Again, if you see, all the explanation is here. So it is K fold cross validation. It splits the whole data set into K equally sized subsets. Fine. So again you will have a holdout sample and the other sample becomes the training sample. Fine. Number of repetitions. So number of repetition is 10 times it will be repeated. So if it is number of repetitions we are keeping 10, number of folds 10. So again in one repetition, 10 holdout sample will be kept aside. In the next repetition, another set will be kept aside. In the next repetition, another set will be kept aside. Fine. So that is your 10. That is your K cross fold validation. So always remember, you should select K on the basis that the minimum sample size criteria should be met. So let's click on start. And if you see here, calculating 10 fold using these 10 repetitions. Now here the interesting results come. How to read these results? First, you have to read the MV prediction summary, which is the manifest variable prediction summary. This is what you have to read in the Pls Predict. Now, here is another catch in this. So let me first copy this table to the Excel and help you understand one thing which we are talking about. Let's just copy this, come back to our Excel and paste the table here. So if you see, this is your Pls results. So this is, I will write Pls results. So these are actually the errors produced by the results of the Pls. Now the beauty of the Smart Pls is gives you the naive benchmark also, which is the LM. linear model results. So if your data has been run on a linear simple model instead of the partial least squares, then what could be the errors? So we click on linear model. Again, I'm copying the results and taking it to the Excel. So these are your linear model or the naive benchmark results. As per the literature, we do not go for MAPE. So by default, I am removing the MAPE. We have to now look for these two things. So one is root mean square error. Other is mean absolute error. Root mean square error. Other is mean absolute error. So what they are telling you, the mean absolute error actually is the magnitude of the errors in a set of predictions without considering their direction, because it is absolute. So without considering your direction. So again, it is the average of the absolute difference between the predicted value and the actual observation. Root mean square is square root of that average. Mean absolute is without considering the sign, the difference, average. Root mean square is taking the square root of that average. Now when we are talking about that which column we should read and represent the results. So the literature says that if your errors are distributed normally, then go for checking the RMSE results. If the errors are not distributed normally, then check the MAE results. So let's have a look. So you have the histograms available here itself. See the histogram, PLS, MB error histogram. So here, with respect to the dependent variable, each construct, the histogram is present. So you have to see whether these histograms are normally distributed or not. So as per we are saying by the graphical display, these are not normally distributed. These are not bell curves actually. It seems that there are scatterness, too much scatterness is there, and some of the values are totally out with respect to the data. So we can't say that this is the normal distribution. Another way, if you find it difficult to assess using the diagram, using the chart, then what you can do is, here if you see in the final results, see below in the final results when we are talking about. So in the final results, you can go for manifest variable predictions and the errors. So here your errors are there. So just copy them, take it to your software, maybe SPSS or maybe R or anywhere, and check with respect to the normality of the errors. So if the errors are normal, then go ahead, interpret the result on the basis of the RMSE. If they are not normal, then MAE has to be read. So as per the histogram analysis, these are not normal. These are not normal. So what should we do? We go back to the MB results, and now I will read the MAE, PLS MAE. So I am removing these. I will not read RMSE. So let me copy them here. These are not required. So here what you have to do is, you have to calculate the difference between the errors produced by the PLS and the errors produced by the linear model. So PLS MAE minus LMMAE. So if all the values are negative, if all the differences are negative, then it means that PLS has produced as compared to the same model being done in a linear model or a naive benchmark basis. Thus we say the model has high predictive power. All are negative. All are negative. So then we say it is a high predictive power. High predictive power. And if you will find out that one or let's say two are positive, then it is medium predictive power. And if majority are positive, that means no or low predictive power. Low or no predictive power, which is not a good sign. That means maybe the PLS is not a suitable method for your model, so you should have done it on a simple regression analysis, not a PLS least square analysis. So it is recommended that you should move ahead with your research with respect to applications and all when you have at least medium predictive power. So this is about your Pls Predict results, and this is how you should represent the results of the Pls Predict model. And you have to tell them that why the MAE has been considered, not RMSE has been considered, because the errors were not normally distributed. That is why we have represented the MAE. We have based our results on the MAE. Fine. So this is about the prediction power of the model. So your model is able to predict well, your model is good, so somebody else will put in their data onto your model, so the chances of getting a high predictive power is good. Again, pausing here for your questions. Any questions? Again, Saidu, discriminant validity has been discussed in the first video, so I would request you to please go through the first video, because right now we have moved ahead from this. Again, see, any version of Mr. Mohammed Hussain, any version of the Smart PLS you can work on. They have recently launched the Smart PLS 4 as well. So go ahead, use that version. So all have similar way of performing, all have similar way of doing. See, how to interpret blindfolding? Simply, you have to give the value of Q square. You just have to mention the value of the Q square. That the Q square value is this value, it is greater than this number. So it means that there is the moderate predictive power or the high predictive power. That's it. Nothing more has to be written with respect to the Q square. I will show you some of the papers as well. How to write about when you're talking about the blindfolding, when you're talking about the Pls Predict. I'll show you some of the papers as well. Oh, is my voice clear to everyone? Because some of you are saying that the voice is cracking.
Yes.
Any other question, anyone?
Yes, actually participants have been complaining of your voice a bit cracking. So if you don't mind to check your microphone, would be good.
Okay. So now is it clear? Because from my side it is not showing any sign of this.
I think it's okay. It's clear. It's bit of sound there, but it's all right. You can continue, please.
Okay. Any other question anyone has? Any other question? Because we completed the structural model now. We completed how to assess the structural model, how to report the results of the structural model, how to assess the explanatory power of the model, how to assess whether my model has a predictive power or not. Outsample prediction power we have checked with respect to the blindfolding as well as the Pls Predict. Pls Predict, I always recommend that please present the results of Pls Predict. It adds value to your paper. Now I am moving towards the mediation analysis. So what is a mediator? It is very important for all of you to understand what a mediator is. So mediator, as we say, it is a helping person. So when somebody is helping you, so it is mediating. So likewise, when you talk about these softwares, when you talk about the variables, so if the variable is helping some other variable build a relationship, then we say it is a mediating effect. Then we say it is a mediating effect. So he is a mediator. He is helping me build the other relationship. He is helping me build the other relationship. Mediation, if we talk about, I always give this example that there is a relationship between a mother and a daughter. There's a relationship between me and my mother. So there's a good relationship is there. Now comes my daughter. Now comes my daughter. So my daughter relationship with her grandmother would be mediated via me. So I am the interlinkage between my mother and my daughter. So I am a helping hand. I am helping them build a relationship. So the granddaughter and grandmother are interacting well. So I am a helping hand between them, building their relationship. So I am transmitting the effect of the daughter, my daughter, on a dependent variable, which is my mother. So that's a simple relationship. That's a mediation when we are talking about. And diagrammatically, how we show the mediation. So this is how, in terms of the diagram, when we are talking about it, how we show the mediation. So this is how you show. So x1 is actually your independent variable. X1 is independent variable. This is my IDV. Y is my dependent variable, right? And then comes my x2. It is my mediator. It is my mediator. So my daughter is, I am the linking between my daughter and the relationship with my mother. So my daughter is interacting, it is here helping the mediator, and then going forward to the grandmother. Mediation, helping. We are helping, we are building, we are helping. What is this beta 1, beta 2? So this is the direct relationship. Beta 1 is the direct relationship between the independent variable and the dependent variable. Beta 2, beta 3 are the indirect relationships. How the indirect relationship? So beta 1 we say is the direct effect. Beta 2 multiplied by beta 3 is actually the indirect effect. It is the indirect effect which is being mediated through x2. So this is mediation. So mediator must be the causal result of the independent variable and the causal antecedent. So one must cause the other. And when we talk about the moderation, to see the change in the diagram representation. So here x2 is the moderator. This is your dependent variable. This is your independent variable. So theoretically, this is what the moderator is doing. It is actually moderating. It is actually changing the relationship. So the relationship may hold true or it may not hold true when comes the moderator in effect. Fine. So the relationship between the x1 and y depends on the value of the moderator. So moderator may either, strengthen or may weaken this relationship. May strengthen or may weaken this relationship. So we say the moderator actually tempers the relationship. We say the moderator actually tempers the relationship. So that is a simple difference between the mediator and the moderator. So if I simply put it with some of the examples here itself. So let me just clear the screen and just put some of the examples for all of you. So let's suppose, I am saying that, okay. So let's suppose your age impacts the medical status, which further impacts, having the chances of the car crash or any accident. It is a possibility? Yes, it is a possibility, because age actually impacts our medical requirements, our medical status, our things, our body, everything. See another one. When we are talking about a gender, so if I am saying that exercise is impacting the weight loss, is it true? Yes, it is true. The exercise impacts the weight loss. Now let's say, does this relationship remain the same when we say that we have the age also involved? So if I am saying I have the age also involved, so what will happen when the age is also involved? So does your exercise impact the age? Means, does it flow like this, that the age is impacting the weight loss also? Means I am saying exercise is impacting the age and age is impacting the weight loss. Is it possible? No, because age is decided by birth. Exercise will never, bring a change in my age. I may feel younger, but my age will keep on increasing even if I do exercise or not. Right? So here age is not a mediator. So what an age is? Age is actually moderating. Age is actually moderating this relationship. Age is actually moderating. So with the change in age, this relationship may also change. That the younger age people are tend to have a better weight loss when they are doing exercise. So maybe when the people, move to the more, older ages, so their actually weight loss capacity, their way of doing the exercises may or may not do the exercises, will change. So here what the age is doing, age is actually moderating. Age is actually moderating, not mediating. So always remember, when mediation, for mediator, one must cause the other must cause the other. Means we are saying x1 must cause the x2 and x2 must cause the y. Then only we say it is a possibility that the mediator exists. So this is the mediator-moderator simple basic difference. What is the meaning of both of them? Just to give you an idea, just to help you differentiate that this is how things work. This is how you should understand this is a mediator, that is a moderator. Now moving ahead, different types of mediations we have. So we have here is serial mediation. Now what is a serial? That is a simple mediation. The earlier one is a simple mediation when we are having only one way of going So here it is the mediator, X2 is the mediator. So it's a simple mediation. Now when you have multiple mediators, 1, 2, 3, so these are multiple mediators, then it is known as serial mediation. So it can be like this also, X is impacting M1, M1 is impacting Y, X is impacting M2 and M2 is impacting Y. Again, here what we are showing is that it is the parallel mediation. Why parallel mediation? Because this is path number 1 to reach Y, X to M1 to Y, another path X to M2 to Y, and we have the direct path as well. So this is known as your parallel mediation. Now if you join the mediators also, then it is known as serial mediation. Then it is known as serial mediation. So that is serial and the partial mediation. Now how to read the results, or what do you mean by calculation of these results is, so again, direct effect will be simple. It will be, let me put it here only. So this is a direct effect. I'm adding a line like this. So this is beta 1, this is beta 2, beta 3. So this is your beta 3, this is beta 4, and this is your beta 5. Okay. So now what I'm saying is, so I am saying that it is direct effect is beta 1, X to Y. Now see the indirect effect. What will be the indirect effect? So indirect effect will be including all of these, because it is a serial mediation. The X will go to the M1, M1 will go to the M2, M2 will go to M3, M3 will go to Y. So what will happen is, so it is now beta 2, beta 3, beta 4, beta 5. And what is the total effect? So the total effect is direct effect plus the indirect effect. Total effect is direct effect plus the indirect effect. So that is your mediation. That is your mediation. Direct effect, which directly goes between the independent and the dependent variables. Indirect effect via the mediators. Indirect effect is via the mediators. Now when we are talking about, let's say, parallel mediation, when we are saying that it is parallel mediation, now in case of parallel mediation, what will happen? In case of parallel mediation, now you will have different indirect effects. So when I am saying that the indirect effect we are talking about here is with respect to M1. So M1, if this is beta 2, beta 3, beta 4, beta 5. So through M1 it is beta 2 multiplied by beta 3. Indirect effect of M2, it is beta 4 multiplied by beta 5. And likewise for M3. So we will have 3 indirect effects. We will have 3 indirect effects. And to see that which indirect effect is more significant or which mediator is more significant, in that case, the value of the beta is to be checked. That we will see once we start with our analysis. So I hope the basic meaning of the mediation, the serial mediation, the parallel mediation is clear to everyone. Let me clear all this. Now how to assess whether the relationship exists or not? Partial mediation, then your direct effect as well as the indirect effect, both are significant. So this is the direct effect. This is your indirect effect. When both of them are significant, then we say there is a partial mediation. That means X2 is mediating the relationship, but X1 directly also explains some of the things with respect to the Y directly as well. Then comes full mediation. Full mediation is when your direct effect is insignificant and only the indirect effect is significant. So X1 is able to explain everything with respect to the Y, with respect to the R square value with the help of X2 and not directly. No mediation when the indirect effect is not significant. Only the direct effect is significant. That means X2 is actually not mediating the relationship. It is not helping the relationship. It is directly X1 who is directly impacting the Y. Who is directly impacting the Y. So that is a simple explanation. So all the types of mediations need to be explicitly emphasized with the good theoretical reasoning. Why you are doing a mediation analysis, that means why you have taken this as a mediator, there has to be theory backing it. In terms of the indirect effect, you need to assume that the X has an indirect effect on the Y, even though there is no effect with respect to the X to Y. X, now if you see, X has an indirect positive effect on the Y through M. This is the way of writing the hypothesis. So you can write the hypothesis in this way. X has an indirect positive effect on Y. Or you can simply say, M mediates the relationship, or M positively mediates the relationship between X and Y. When we are talking about partial or full, or actually, you can use a simple mediation analysis irrespective of partial or full. So M partially or fully mediates the effect of X and Y. The effect of X and Y is partially or fully mediated by the M. The effect of X and Y is partially fully mediated by M1, M2 and M3. Or in this, one more thing we usually write when we are talking about a serial correlation, serial mediation also, that M1 and M2 serially mediates the relationship between X and Y. So this is how you can write your hypothesis when we are talking about the mediation analysis. So as per the Rowe et al. Procedure of assessing the mediation analysis, what we do is we actually assess the indirect effect. So if the indirect effect is not significant, then you simply check whether the direct effect is significant or not. So if direct effect is significant only, then again we said no mediation. And in case when the direct effect is not significant, then there is no effect at all. Means neither of the relationship exists. So maybe you are working on a wrong model. So kindly have a look at that. Kindly work on that model, because none of the relationships are coming significant. Now let's suppose what is happening is your indirect effect is significant. Now what is the next step? You have to see whether the direct effect is significant or not. So if direct effect is not significant, that means only indirect effect is significant. So you have full mediation. You have full mediation. However, when direct effect and indirect effect both are significant, in that case we use the word partial mediation. In the partial mediation, you just have to see, what you have to see, that the mediation, if it is positive, that means you have complementary partial mediation. You have complementary partial, assess the sign of A cross B cross C. You have to assess the signs of each of your parts actually. See, when we make a diagram, so this is X, it is impacting the Y, and here is the mediator, right? So we are saying that this is A, this is B, and this is C. So you have to assess the path. So if all of these are positive or all of these are negative, all of them, I'm talking about all of them. In that case, we say that it is a complementary partial mediation. It is a complementary partial mediation. But if one is negative, other is positive, or this one is negative, this one is positive, then you say it is a competing or competitive mediation. And this is not considered a good sign. It is a partial mediation, but it is, we say, competent partial mediation. Competent partial mediation means that any of the parts have opposite signs, then we say it is competitive partial mediation. If both of them have negative, both of them are positive, then we say it is a complementary partial mediation. So this is with respect to the theory of the partial mediation. There are various models, which are actually used when you are working on the partial mediation. Sorry, not partial mediation. Earlier, people used to work on the Baron and Canny approach. So when we are talking about the Baron and Canny approach, so there it was suggested that that if your just 1 minute. So here, they have said that Baron and Canny that if your direct effect is significant, then only you should go for assessing the indirect effect. So it is being questioned by many of the researchers lately. Many of the researchers have questioned that why we are focusing only on the direct effect. Indirect effect plays a greater role. So that is why Baron and Canny approach is not used then, because he suggested that first you run the model without a mediator, check the direct effect. Then you run the model with the mediator, check the change, and then only try and report the results. But this is criticized. And finally, McKinnon, Fairfield, McQuillan, Rucker, and Chin have finally found out a new solution, new parameter, new research to support the things. So they said that we have to check the mediation using a bootstrapping technique. We'll put all the model together along with the mediator. We will not check the mediator separately. We will put the moderator together, and then we will finalize whether it is a partial mediation, full mediation, or a no mediation at all. So that is how the final results come. Now coming towards your working part. So let me quickly show you how you do it into the Smart PLS. So this is our model now. So let's have a mediator in between them. So what I'm saying is that I'm saying the attribute impacts the quality as well. So I'm saying the attribute impacts the quality as well, and then it impacts the performance. So if you see here, I have added now quality as a mediator. Quality is now a mediator, attribute is an independent variable, performance is a dependent variable. Now what we are saying here is that we go to the calculate, we go to bootstrapping, nothing has to be changed, same, you have to go for 10,000 as per the new criteria. Complete bootstrapping, you will go for bias corrected, two-tailed, and let's start. So once we start, it will run the bootstrapping results. It will make it 500 samples right now we are running, and the results are here. See, by default, you will get all the direct results. By default, you will get all the direct results. Let me just copy them and take it to the Excel because it becomes easy to read in the Excel. So let's put them here. So these are my beta coefficients, sample mean I don't require, standard deviation I don't require. Let me delete unnecessary things. P-values, all the P-values are less than 0.01 as well. So all of them are significant at 1% level of significance. So I'm not writing the P-values here as well. What I'm doing is I am marking the star here. I'm marking the star asterisk. So it is actually that, all these are significant. Now what I'm doing is I would be adding the bias corrected interval. So let's add all the things which are required. So this is the bias corrected interval we have. Let's copy them here and let's paste it. So here it is. So bias corrected confidence interval lower and bias corrected confidence interval higher. So this is earlier we used to do. Now, when you have a mediation analysis, please write only those parts for which you have the hypothesis. So do not write the unnecessary part. Always remember, the results will be given for every part which is there in the model. But you may not require all the results. So how? Let's suppose in this model, my hypothesis is this: quality mediates the relationship between the attribute and the performance, and another hypothesis is attribute impacts the performance. These are my two hypotheses. So I will keep only these two parts. So attribute impacts the performance is my hypothesis. Yes, this is my hypothesis H1. This is not my hypothesis that attribute impacts the quality, quality impacts the performance. No, this is not my hypothesis. For as of now, I am keeping it aside. Now my second hypothesis is my actually mediation hypothesis. So where I will find that in the bootstrapping, if you see, there is specific indirect effect. In the final results, there is specific indirect effect. See, path, total, indirect, not specific. In the specific indirect effect, this is the result which I want. Attribute to quality to performance. So, paste it here. Attribute to quality to performance. This is the beta value. T statistic. P value, again, if you see, it is significant less than 0.01. Let's copy the confidence intervals. So these are the confidence intervals. So let's copy them and place it here. So this is your, always remember this. This is your table. So do not write unnecessary parts. The PLS, any software will give you results of all the parts, but only write for which you have the hypothesis. Now, I have to result, let's say, let's not do it. So this is also significant, I am saying, this is also significant, right? Now, if you remember, I told you that the direct effect is there, right? And indirect effect is there. So let's see what is a direct effect and what is an indirect effect. You do not have to do any calculations. Every calculation is done by the smart PLS. I'm just telling you how it is being done, just to explain you. Fine? The values are already in front of you. I'm just telling you. So let's try to have it. So in the diagram, if you see, attribute to performance. This is the direct effect, right? This is the direct effect. So we have to see the attribute to performance. Attribute to performance, it is 0.38. So this is my direct effect, right? Indirect effect is beta 1 multiplied by beta 2, right? Beta 1, which is attribute to quality, and quality to performance is beta 2. The multiplication of these two should be the indirect effect. So let's see. So here are the results of the quality. If you remember, I just kept it aside. Attribute to quality, it is 0.736 multiplied by 0.461, quality to performance, 0.461, and see the value 0.339. And can you see here the indirect effect? See, exactly the same. So software by default gives you the value, but still if you want to calculate, most welcome to do it in this way. How this indirect effect is calculated. Next thing. So these are the results. So I am saying my direct effect here is significant. Direct effect is significant. My indirect effect is also significant. So what I talk about the mediation, this is a partial mediation, because both the direct and the indirect effects are significant. And it is complementary. Why complementary? Because all are positive. All are having the same sign. So it is complementary partial mediation. So how will you write? The quality partially mediates the relationship, positively partially mediates the relationship between the attribute and the performance. That is one. Let's do a change more in the diagram. So what change I am doing here, I am adding one more variable now. So this is the switching cost I am adding here. So this is a switching cost, and I'm saying that attribute impacts the switching cost impacts the performance. So what kind of diagram now we have? So now this is your parallel mediation. Now if you see very clearly, this is your parallel mediation. So there are three ways to reach the performance. One is a direct way, attribute to performance. Other is attribute to switching cost to performance. Other is attribute to quality to performance. So this is a parallel mediation. Again, what we'll do? We'll run the bootstrapping. And please remember, if you run the bootstrapping on one model again and again, you will find some of the differences in the value because it's an iterative process, so differences in the value will come. So here it is. The results are here. Now remember, what is your hypothesis? Only write those values. So let's see what are my hypotheses. Copy it here. So my hypothesis, attribute to performance is my hypothesis. Yes. Here. My hypothesis, attribute to performance. First hypothesis. Second was attribute to switching cost to performance. This is the second one. Attribute to quality to performance. So means I don't require any of these. I don't require them. True? I only require this because this is my hypothesis. Then I have a second hypothesis. Then I have a third hypothesis. The second hypothesis was this only, which we just did it. Fine. And then I have another hypothesis, which is talking about the switching cost. Right? Now, let's see the value of those variables. So let's have the specific indirect effect. In the specific indirect effect, if you see, we have the results. So let's quickly copy. So this is your result and this is the result of the earlier one. So what I'm saying? I'm saying that this is significant, but the switching cost mediation is not significant because the value is greater than 0.10 even. So it is not even significant at 10%. So this is not significant. So switching cost is not mediating the relationship between the attribute and the performance. Only the quality is mediating the relationship. Only the quality is relationship. And since the direct effect and the indirect effect both are significant, so we say it is a partial mediation. So this is parallel mediation where you have two mediators. Now let's suppose, take one example, let's suppose this is significant. Let's just assume that. Let's just assume this was also significant. Now in that case, you have to give an additional interpretation that both the mediations are significant. So quality and switching cost both mediate the relationship between the attribute and the performance. However, quality is the stronger mediator. How did we found out? On the basis of the beta value, path coefficient. On the basis of the path coefficient, the quality has the highest coefficient or the beta value. So we say the quality is the strong mediator as compared to the switching cost. So this is the line when you add, when in parallel mediation, all your mediators are significant, or when we say when more than one of the mediator is significant. Now coming to the last one. Last one is when there is serial mediation. So now what I'm doing is I'm adding a line here. So I am now having another relationship which is attribute impacting the switching cost. Attribute impacting the switching cost. switching cost impacting the quality, quality impacting the performance. So it is a serial mediation. It is a serial mediation. So a model may have parallel as well as serial mediation present with respect to your hypothesis. It depends upon your literature, but a model can have serial as well as parallel mediation both. How to interpret? Again, let's quickly run the results. Go to calculate, bootstrapping, and let's calculate the results. So the calculation is done. Now see the results, and please remember we will only look for the results which we want. So Excel, let's go to the Excel please. Save the results. From all of this, I only require attribute to performance because that is my only hypothesis. Other than that, I require the indirect effect. So here it is, my indirect effect. Excel. Let's go back to the Excel and copy. So which indirect effect we are looking for? Here I am looking for the parallel as well as serial. So parallel, it is attribute to performance, attribute switching cost to performance, attribute quality to performance, and my serial mediation. So these three I am looking forward to. So see here. So this is your parallel. This is your parallel mediation. This is also your parallel mediation. This is your serial mediation. And this is actually your direct effect. So if you see, this is significant. This is not significant. This is again attribute to quality to performance. If you see a change here, it has become not significant. However, in our earlier calculations, it has been significant. So that means now the parallel mediation doesn't hold when we have a serial mediation. So what it is telling you is a very important interpretation, very important finding, that attribute relationship with the performance is serially mediated via switching cost and the quality. So attribute impacts the switching cost, which in turn impacts the quality and which leads to a better performance. So in this case, parallel mediation doesn't hold good. They are not at all significant. So this is how you go for simple, parallel, or the serial mediation. Any questions? Because now we have covered the topics which we have decided to take it on. So any questions? The session has been long. See, Salmanji, I have already told you the Q-square value will only come for the dependent variables, not for all the variables, only the dependent variables where the arrows are pointing out. So you interpret the predictive power only for the dependent variable. Sorry, Moji ji, I am not able to understand your question. Can a model have both? What both you are asking for?
I think the student is asking for whether a model can have mediating as well as moderating together.
Yes, we can have mediating, moderating together. Or you can have different types of mediations together, like I shown you, parallel and serial mediation together. See again, Peaches and Hairs has the recent one again. So Baron and Kenny is not used now because their whole agenda was to run the model separately. And Hairs and Peaches, Chin when you talk about, McQueenan if you talk about. So all of them are actually talking about putting the whole model together and then assessing for whether there is a presence of mediation or moderation. How can we distinguish a related variable to serial or parallel mediators? Again, literature will help you. You have to dig deep into the literature. You have to dig deep with respect to the relationship between the variables and how they can act like this. Then only you can basis that, this variable impacts this one, then it goes to another one, and then the impact comes on the dependent variable. Any other questions? Yes, it is necessary to report. If you remove 2-3 items, it is necessary to report Shakir. And I have also mentioned this thing in the video 1, so please go and have a reference from video 1 as well. You should definitely report the same. Next question.
That's it. There's no more question.
Okay.
Well,
Okay, that's great.
okay. Then let me add the moderator.
Thank you so much, Dr. Paro, for this amazing webinar. I hope all the participants understand. And if you guys have any question, you can kindly message us online. And once again, thank you so much, Dr. Paro, for this amazing. And I hope to meet you back again in the next webinar. Thank you so much.
Thank you so much. It's my pleasure. And there is one question which popped up right now. So yes, I just answered it. You can have the mediator moderators both. So we can have the moderator like gender, or you can have, age as a moderator, or some other, even a scale variable as a moderator, mediator, both. So it is quite a possibility. Thank you so much.
Hi, Shireen. I think you can conclude the session. Dr. Parul, anything you have to say? Final word for the participants. Participants, please fill in the Google form in order to get the certificate. We have given you the link at the chat box. Please fill in the form accordingly. Okay, Dr. Parul, any advice towards the end?
So advice is that, please read, please review the first one and then jump to the second video. It's my humble request because some of your queries relate to the first video, first session which we conducted. So please go through that, review it, take your notes down, and then move towards doing this mediation perspective and giving the results.
Shireen, now the session is to you to conclude. Shireen.
Yes, Prof. Thank you so much again, Doctor, for this amazing webinar. And I hope I can meet you in the next webinar. To all the participants, please practice. In case you have forgot anything, you can watch this video we'll upload in our channel. So don't forget to subscribe our channel platform Research Development. Thank you so much.